Equations and identities. What is an equation? How is it different than an identity? Take a moment and discuss in your groups what you think is the difference and what is an equation. An equation is created when two expressions are set equal to one another such that they are equal for some values of their variables but not for all. So they are set equal to one another. If they are equal for all values of their variables, then that is an identity, not an equation. So not all mathematical statements which include an equal sign are equations. Some are identities, and it's very important to be able to distinguish between the two. Here are some identities. So we have 2 plus 3 equals 5, 9 minus 2 equals 7, 5 times the quantity x minus 3 equals 5x minus 15, and 0.5y equals y divided by 2. These are always true. There are no values that can be assigned to the variables for which these would not, or for which these would be untrue. Here are some now equations. We have s equals 15 over t, v equals 12 minus 9.8t, x equals 10 plus 6t minus 4.9t squared. In all of these cases, the variables are interdependent. They are only true for certain sets of variables, not all variables, or not all values of the variables. So let's look at this last equation. X equals 10 plus 6t minus 4.9t squared. Changing the value of t on the right side of the equation changes the possible values of s, v, or x on the left. So here we have it would change the value of x. Here it would change the value of v. Here it would change the value of s. And vice versa, if you change the value of s, v, or x, it would change the value of t. These are equations, not identities, since knowing the value of one variable changes the possible values of the others. Here are our three equations again. So above are simplified physics equations in which t represents time, s represents the speed, and v is for the final velocity, and x is for the final position. In these equations, we only have two variables, but in later math courses, there will be more than two. For instance, here are more general versions of these same equations. We have s equals d over t, but now we have v equals v naught plus at, and x equals x naught plus v naught t plus 1/2 at squared. So these are a little bit more complicated physics equations. In these cases, there are up to 5 variables which all depend on each other. They're all equations. It's important to see that equations define the relationship between variables since the equation is only true for certain sets of values. It's a relationship. It does not work for all numbers, all values for the variables, like an identity would. So let's use this table to find some solutions to the equation s equals d over t, where s is representing the speed in meters per second, d represents the distance in meters, and t represents time in seconds. So s equals d over t is representing speed equals distance over time. It's a very popular physics equation. So we've entered the distance traveled in the first column and the time it took to travel that distance in 2 of the columns. So here, we're going to use the equation s equals d over t to find the speeds and fill in the blank column. So if we're following our equation s equals d over t, we have s will equal 30 divided by 2. And if we simplify, will give us 15. S equals d over t. So for the second row, we would have d over t, 60 over 4, which simplifies to 15. 90 and 6, 90 over 6. again simplifies to 15. Here, the fourth row, now we have 120 d over t, 120 over 2, which now simplifies to 60. The fifth column, we have d over t, 240 over 4, which simplifies to 60. And the last row, 360 over 6, d over t, which also simplifies to 60. So now we have our speed column filled in. Note that in the first three sets of answers, the object was moving at a speed of 15 meters per second, and the final three sets of answers for an object traveling 4 times faster at 60 meters per second. They're for that object. But in all cases, knowing the value of 2 of the 3 variables determines the value of the third. We knew the values of the distance and the time, the d and the t, so we were able to solve for the third, which was s. Knowing any 2 of the values determines the third, since they have a relationship in the equation. So try it in this case where the equation is still speed equals distance over time, s equals d over t, but the values of different variables are provided. Can we still figure out the unknown values and complete this table? Let's try. So here, the first row, we're given the distance and the time. So we would have speed equals distance over time, 20 over 2, which simplifies to 10. So this case, we were able to see the speed. Now we're missing the distance. So we're given the speed is 20, is told that the distance over the time, which we're told is 5. Now we have to, this is a little harder. Now it's not just dividing the numbers. We have to think, well, what number divided by 5 equals 20, which we can figure out is 100. So the distance would be 100. Now, the third row, we're given the distance of 100 and the speed of 10, so now we're missing time. So here we have a speed of 10 equals a distance of 100 divided by the time. So now we have to think what a 100 divided by what number gives us 10. And we know that that would be 10 as well. So the time would be 10. For the fifth row, the fourth row, we're given the distance and the time, but not the speed. Similar to the first row, speed equals distance, 120, over time, 2. So simplifies to 60. Here we're given the distance and the speed, so the speed 80 equals 240, the distance over time. So 240 divided by what number is 80 would equal 3. We have to think would be 3 seconds. And finally, we're not given the distance, but we're given the speed is 60. Equals some distance divided by 6. So we have to think what number divided by 6 would give us 60 would be 360. So 360 meters. So we were able to fill in our columns and rows, our missing values, but it was a little harder. We had to think of different operations to use rather than just dividing. It was more challenging since the equation is solved only for s, not for d and t. Filling in values will be even more challenging when we work with equations that have more variables. Again, this is only 3, s equals d over t. So we need a way to solve an equation for any variable, not just have it solved for s, so that we can find its value given the others. It would have been a lot helpful if it was solved for d or t instead of s when the first and second columns were blank. Solving an equation for a variable means to get it alone on the left side of an equation. So whenever you see the directions to solve for a variable, that's what we mean. Get it alone on the left side of an equation. And this is going to be very helpful as we move forward with solving equations in general.